All right, welcome to The Explainer. I am so incredibly pumped you're tuning in for this one. Today, we're taking a seriously cinematic deep dive into the high-stakes mathematical tightrope that is the global supply chain. Just picture a world governed by blazing fast data streams, massive satellite view transitions, and absolute ruthless mechanical precision. Because in this world, literally every single item you buy, it's the result of an incredibly delicate high-stakes calculation. And today, well, we're going to decode the whole shebang. So here's a really fascinating puzzle for you. How exactly do these global giants sit on millions of dollars in physical inventory without, going completely bankrupt? Like, how are they balancing absolute market dominance with the very real, very terrifying threat of catastrophic financial failure? Ultimately, it all boils down to surviving this relentless, never-ending cycle of supply and demand.
Just take a look at this absolute behemoth of a setup. It perfectly captures the physical chaos of the global grid. But see, right beneath those massive blue cranes, there are these invisible, glowing data streams that are literally taming the physical world. The folks managing these supply chains, they're essentially the architects of those data streams, and they rely on two very distinct mathematical buffers to keep this whole massive system from just collapsing on itself.
Now, the architecture of all this inventory really comes down to two foundational pillars. First up, we've got cycle inventory, which is all about exploiting economies of scale, buying in massive bulk. And then floating right next to it is safety inventory. Think of this as your ultimate buffer. It's your armor against the chaotic, completely unpredictable nature of the real world. So let's go ahead and unpack that first one.
Okay, so cycle inventory. Simply put, it's the average amount of stock you use to satisfy demand in between your shipments. But why hold it at all? Well, because companies absolutely need to exploit economies of scale. Let's look at the Saba Tea Cooperative over in the agricultural sector. Because tea is a seasonal crop, they have to order and produce in these massive batches. This cycle inventory lets them efficiently, and very deliberately I might add, mismatch their supply and demand. It means they can consolidate their shipments, totally optimize how they load their vehicles, and fundamentally drive down those procurement costs per unit.
But here's where we hit a massive tension point in the system. It's like having two incredibly heavy weights sitting on a scale. On one side, you have holding costs. If you order way too much stuff, the cost of the capital, the warehouse space, and the risk of the product just going obsolete, it'll literally eat your margins alive. But then, on the flip side, you got ordering costs. If you order too little, or if you order too frequently, you just get crushed. You're paying fixed setup costs, massive transport charges, and endless paperwork every single time a truck rolls up to your dock.
Now check out that intense flare of light right there at the intersection. That exact point, where the downward slope of your ordering costs perfectly crosses the upward slope of your holding costs. That right there is the mathematical savior of the entire supply chain. We call it the economic order quantity, or the EOQ for short. It is the exact mathematically perfect lot size that minimizes your total annual costs. It's the absolute sweet spot.
Let's actually ground this with a real-world example. Say, Best Buy. Imagine Best Buy sells, 12,000 computers a year. Every single time they place an order, they're hit with a fixed $4,000 charge for setup and transport. Now, keeping a computer sitting in inventory, that costs about 20% of its $500 value every single year. When you plug those exact figures into the EOQ formula, it spits out this incredibly beautiful, precise number. To keep their total costs absolutely as low as possible, Best Buy shouldn't order 500 computers, and they definitely shouldn't order 2,000. They need to order exactly 980 computers at a time. Period.
But listen, the EOQ, it assumes we live in a perfectly rational world. And we all know we don't. So what happens to all this perfect mathematical harmony when actual human behavior enters the chat? What happens when a manufacturer suddenly decides to offer a short-term trade promotion, say a totally harmless-looking 5% discount?
Absolute chaos. Seriously, that's what happens. Just look at the violent spikes on this chart. That tiny 5% discount triggers this massive behavioral trap that we call forward buying. Basically, retailers get greedy, right? Instead of just ordering their optimal lot size, which let's say is around 6,300 bottles of a product, they try to totally exploit the discount. They forward buy over 38,000 bottles. They're buying almost 4 months' worth of inventory in one massive shockwave, completely and totally wrecking their cycle inventory.
And this exact human fluctuation is one of the biggest contributors to the dreaded bullwhip effect. Because think about it, the retailer now stops ordering entirely for months while they slowly burn through those 38,000 bottles. So what happens? Production lines stall out, transportation routes go totally cold, and ironically, despite grabbing that discount up front, the total profits across the entire supply chain actually drop. Why? Because of the massive explosion in holding costs and just the pure system-wide volatility they just created.
And hey, volatility is actually the perfect segue here. Because even if you are a master of cycle inventory, and even if you perfectly avoid that discount trap, the EOQ formula still assumes that your demand and your lead times are perfectly known. But we live on a spinning globe. Perfection just doesn't exist out here. And that is exactly where we need to bring in our second layer of defense.
We need safety inventory, because in the real world, things go wrong all the time. Forecasts completely miss the mark. That's your demand uncertainty. Your suppliers get hit with random delays or terrible quality rejections. Lead times suddenly jump all over the place. And man, especially if you're in agriculture, you are constantly battling the absolute wrath of weather, pests, and these massive, unpredictable crop fluctuations. You literally have to hold a buffer stock just to survive the wait. A great case study for this is the Dole Food Company. They deal with highly perishable agricultural products. If a massive storm delays a whole shipment of pineapples, they can't just hit pause on the supply chain. The product is literally rotting. So Dole has to manage their agricultural safety stock with just ruthless precision. They're constantly buffering against weather variability to keep their reputation for reliability totally intact, but doing it without letting a bunch of excess inventory just degrade in a warehouse somewhere. So, the big question. How on earth do you hold enough safety inventory to actually survive without completely bankrupting yourself on those brutal holding costs we talked about earlier? Well, you deploy this strategic masterclass known as aggregation. It's exactly what it sounds like. It's the act of centralizing your physical inventory to drastically lower the total amount of safety stock you actually need to hold across the board. Seriously, look at the sheer raw power of the math behind aggregation. Say you've got a vegetable distributor and they're serving 9 different retail districts. If every single district holds its own safety stock all by itself, they each need 100 units. Boom, that's 900 units total. But if they pool all that inventory into one central mega warehouse, the math completely transforms. Because a sudden spike in demand in one district perfectly offsets a lull in another district. So the new requirement, it's just 100 times the square root of 9, which is exactly 300 units. That is 600 units saved. Just by changing the physical architecture of where the stuff lives, this distributor completely eliminated 2/3 of their safety stock. And the best part? They maintained the exact same level of customer availability. I mean, come on, that is just a stunning mathematical victory.
But wait, we can actually push this even further. We can use these incredibly advanced manufacturing strategies called component commonality and postponement. So instead of trying to perfectly predict exactly which highly customized product a customer is going to want weeks from now, you build a flexible foundation. You basically keep the wireframe gray until the absolute very last possible second.
So the crucial takeaway here is this 3-step dance. Step 1, keep your components common across as many products as possible. Step 2, because those components are common, you get to aggregate the demand, making it super predictable. And step 3, you postpone or totally delay the final customization until the very moment the customer actually places the order.
Think about Dell servers. By using the exact same processors across 27 totally different server models, they aggregate all that demand and slash their component inventory. Or think of a local hardware store selling paint. They are not keeping hundreds of cans of very specific weird colors in the back. No way. They just stock a common base paint, and they totally postpone the color mixing until you're literally standing right there at the counter. By doing this, paint retailers took their required safety stock from a staggering 2,326 units all the way down to just 233 units. That, my friends, is the absolute superpower of postponement.
So, bringing it all back home. We return to the physical chaos, but now the digital data streams are perfectly harmonized. Because you now know the 2 great pillars. Cycle inventory, that buys you scale and it buys you massive efficiency. Safety inventory, that buys you pure survival against the wild, unpredictable chaos of the real world. By mastering the EOQ, completely dodging that forward buying discount trap, and perfectly utilizing aggregation and postponement, you can actually command the global grid. But, as we know, the grid literally never stops moving. You've mastered the mathematical balance of today's supply chain. You know exactly how to optimize your costs and buffer against the variables. But I want you to ask yourself something. What happens to your beautifully, carefully calculated safety stock when the next completely unprecedented global disruption hits tomorrow? Keep questioning everything, and I will see you on the next explainer.